Well, hello everybody, this is Chris back again with the Ancient Scholar. I just want to go ahead and wrap up the terminology that I was talking about a little earlier in adaptations in cells and tissues. Obviously, a cellular adaptation is going to lead to a tissue adaptation. And just because these cells are adapting doesn't mean they're adapting in a good way. So, let's just go ahead and recap real quick. We talked about atrophy, a decrease in the size of cells. Hypertrophy, increase in the size of cells. Note that I do not have an increase or decrease in the number of cells, just the size. So atrophy and hypertrophy talk about the size. Hyperplasia is an increase in the number of cells. Dysplasia is a cell that loses its specialized function. And now we'll go ahead and talk about metaplasia. Metaplasia is generally thought of as a reversible adaptation. Generally, not always, but generally, we can say that there is some reversibility. And basically, what happens is one type of cell is replaced by another cell. So one type of cell, perhaps those cells have been altered to the point where they've lost their ability to function, and another type of cell is produced or kind of takes over. A good example of that when we talk about respiratory therapy, because this is geared more towards respiratory therapy, would be somebody who smokes, a chronic smoker. And when we talk, and I know you guys will be covering this or may have already covered at this point in your respiratory anatomy and physiology module that you have to take first semester, when you talk about the tissues and cells of the lining of the airway, when we talk about certainly the lining of the upper airways, what we have columnar pseudostratified ciliated epithelial tissue, and we know that the cilia beat in a kind of a sweeping motion, and we have goblet cells and other mucus-secreting cells secrete mucus. There's a layer of mucus that lines the inside of that airway. The mucus is very similar to a fly trap. It traps particles, foreign debris, and matter. It gets trapped, it kind of sticks to that mucus, and then the cilia sweep the mucus up, and that mucus eventually gets swept up to the glottic area, and of course that stimulates other reflexes. I notice something is there, and I'll either go clear my throat or swallow and get rid of that mucus. So that collectively is known as the mucociliary escalator or the mucociliary transport mechanism. Now, people that smoke, we know that cigarette smoke inhibits the mucociliary escalator. I smoke, you paralyze those cilia, first of all, and you cause changes to occur. You cause that normal pseudostratified columnar epithelial tissue to quit working, and what happens is squamous cell epithelium actually comes in and takes over, essentially. It's called a squamous metaplasia, where the normal tissue, the pseudostratified columnar epithelial tissue, basically is no longer functioning properly, and the squamous cells come in. Now, the squamous cells do not have functional cilia. They do not have they don't secrete like the pseudostratified columnar epithelia. They don't have the specialized functions that the original tissue had. So as you can expect, people that smoke, certainly people that smoke chronically, are going to have some problems develop due to this metaplasia occurring. They're going to have more difficulty clearing mucus out of their airways, making mucus, making normal mucus, and clearly this can lead to some problems. So already, fairly early on in our pathophysiology, we're already talking about some of the respiratory implications based on just the terminology. Okay, so let's go ahead and I'll go ahead and show you guys some more of my bad art here. So I've just kind of drawn a picture. So here I have normal cells, and then I have abnormal cells, or maybe not necessarily abnormal, but cells that have maybe undergone adaptation. Okay, so here we have hypertrophy, and you can see normal cell and abnormal cell. The cell is much larger. Here we have a normal cell, and here we have atrophy, and I have kind of a shrunken down, shriveled up cell there. Notice that the actual number of cells hasn't changed. Okay, and then we're going to move down to hyperplasia. So here I have my normal cell, and here I have hyperplasia. I have many more cells being created, right? Hyperplasia is an increase in the actual number of cells. Here I have dysplasia. So I have kind of a round-looking cell here, and you have these cells that have undergone dysplasia, and you can see that their shape has radically changed, and they've lost some of their specialized functionality. And then I have metaplasia here, and here I have the normal cell, and I kind of have the normal cell going away, and it's being replaced by this square cell, another type of cell. And obviously this will result in another type of tissue. Okay guys, so hopefully that kind of cleared up some of the terminologies, really good terms to know, and hopefully you're finding things fairly intuitive up to this point. Alright, take care everyone.